Okay, so in this first video, we're going to look at vowel perception. The easy part about this is that at one level, the perception of vowels is all about formants. Uh, the main difference here from what we covered in the acoustic section is that perceptually, we talk about formant pitch rather than formant frequency. Although in practice, we often hear about formant frequency even when we're studying perception, because the differences between those two aren't always materially relevant to the questions in front of us. So a lower pitched F1 corresponds to a close vowel, a more close vowel. Greater distance in pitch between the first and second frequency corresponds to more front vowel. Lower formant pitch overall, especially for the high formants that aren't affected by tongue position so much. Lower formants overall indicates a rounded vowel. There's a couple of sources of variability that make that picture more complex. First, articulatory context can cause one instance of a vowel to end up with different formants than another. This can be due to co-articulatory and/or phonemic effects. For example, palatal consonants could bring the tongue body higher during neighboring vowels, and velar consonants could bring it further back, for example. It can also be a matter of speaking rate. If there's less time for the tongue to get from one place to another, it may not make the full journey to, say, close front position before moving to its next task, maybe somewhere in the back of the mouth. And that's called vowel undershoot, where it doesn't quite reach the position it's shooting for. Um, One of the listener's tasks is to incorporate all of the relevant contextual information about the sounds and the words and speech around it and make adjustments so they can perceive the correct vowel. A lot of that happens automatically, of course, you may not be conscious of it. The task of identifying variable inputs as examples of the same percept, such as the same vowel phoneme, is called equivalence classification. Okay, the second source of variability is the biological and social variability between speakers. Listeners need some strategy of vowel tract normalization to translate the perceived pitch of different formants into a useful vowel identity. We distinguish between two possible overall strategies for normalization when we're perceiving any particular vowel. There's extrinsic normalization. Ta-da. It draws on information from sounds around the vowel being perceived in order to determine what that sound is. So we can look at the idea of point vowels and point normalization. Point normalization as one way to do extrinsic normalization. So let's say we perceive a vowel with a particular, or we're working to perceive a vowel with particular formant values. Point normalization has us situate that relative to some other vowel that has already been perceived. So in this example, we've perceived an oo, and then we can tell from its formants relative to the vowel in front of us that this vowel is, say, an o. So that's point normalization. Another form of extrinsic normalization is range normalization. So here we have a vowel we're trying to perceive, and instead of having necessarily recognized anything, we just notice there's a whole bunch of other vowels, and they build a picture of the vowel space. And so then we can say, oh, this vowel seems like it's around the eh position, given this range. Okay, so that's two different ways of looking at extrinsic normalization, which means normalization that helps us identify a particular vowel's identity based on information outside of that vowel. The other kind of normalization that we can think about is intrinsic normalization, where it uses the various perceptible properties of the sound we're trying to recognize to compensate or to deal with those differences in actual formant values. So, for example, someone with an anatomy that tends to produce higher frequency formant values tends to be a shorter vocal tract. That person will also tend to have shorter vocal folds, and so their fundamental frequency will be higher. So the fundamental frequency on a vowel can be used to calibrate, is this a high or a low formant to a certain extent. And we can also compare the formants to one another. So those are a couple of things that people can use in by way of intrinsic normalization, looking at data information from within the sound you're trying to perceive itself to calibrate where we are in a vocal in a vowel space, formant space, for example. Now, the in this section of the textbook, the Reitz and Youngman textbook, there's also a bit of discussion of exemplar-based theories of perception, where perception isn't guided by building an internal model of the patterns in speech, like we saw with the normalization, for example, but by just remembering what has been heard, what what categories they were recognized at, and comparing that to what's in front of you now in terms of what sounds you're you're trying to perceive. There's some interesting questions around that comes up with some of these. With point normalization, you have to have already recognized one vowel before you can use point normalization to identify another vowel, right? With our example here, you had to have recognized the oo first before you can use it to help you recognize the o. Um, with exemplar-based theories, you have to have recognized the earlier example in order to use it as a way of identifying what category this thing in front of you is, right? You just say, I heard something like this before, but you didn't already know what category that was. It's not going to help you identify what category this thing you're trying to perceive now is. So with both point normalization and exemplar-based theories, you have to have, they inherently need some other strategies helping out to get those reference points. So these are some of the things that linguists have to think about. It doesn't mean those theories are wrong. It just means they're not complete. Other theories probably also not complete, but they don't sort of immediately stumble at that place. Anyway, so that is a little introduction to perception of vowels. In the next video, we'll move on to perception of different classes of consonants.